Our new lesson will be on polar coordinate systems. Now, for the polar coordinate system, we see that it is a series of concentric circles and an angle reference line. The common center of the circles is called the pole. So here what we are used to seeing as the origin will now be referred to as the pole. So be careful with that. Inside our polar systems, we have what's called polar coordinates. And very similar to what you were used to seeing with X and Y, we now are going to look at R and theta. R is going to be some radius that we're given, and theta is going to be an angle. And notice that angle will be measured in radians. So let's look at how the two are related, because believe it or not, they are related somehow. So let's take us a nice right triangle over in the first quadrant, and we know this side here, this is our X length, and we know this side up here, well, this is our Y length, and we also know this here, this side over here, that was labeled R. So a lot of times with our Pythagorean theorem, we were told that x squared plus y squared equals r squared. Now this r here, well, that's the same r as this radius over here. And we also have an idea where we're looking at some angle, theta, which is this theta here. Well, based on what we're given with x and y, notice we're given the opposite side, and then we're also given the adjacent side. So I also know tangent of that angle inside there is going to be equal to y over x. Notice x and y, that's going to be your rectangular coordinates. That's what you're used to working with. Those are rectangular. Whereas if you talk about a distance or radius r and the angle at which that radius is, that's going to be your polar. Well, how can I come up with some kind of conversion between the two? Well, if we remember back to our unit circle, we could talk about, let's see, if tangent of theta is y over x, well, we also could say, well, I know cosine of our theta, cosine of theta is going to be adjacent over our hypotenuse, r. So notice if we multiply both sides here by r, we have a nice little conversion for x, or rectangular into polar. X is r cosine theta. And the same would be true if we wanted to do with y and sine. Well, here we could say, well, sine is y over r, so r times sine of theta, well, that's going to give me a nice value or a nice conversion for y. So notice here we have a way to convert between the two. So if we can keep in mind these nice little conversions, and that's going to help us, but also knowing where these came from will also be useful. Okay, also talking about equivalent points with this, keep in mind that these two values, or these two coordinates, our radius and angle is equal to another radius, or the same radius with a different angle, then alpha and beta, they're coterminal angles. That means they're going to start and stop the same place. And the same is true with these. Now, we're not going to work a tremendous amount with these. It's just a fact that's stated there. For this set of problems, we need to convert polar coordinates into rectangular coordinates. In the earlier slide, we saw in order to do that, we developed the formula x equals r cosine of theta, and we saw that y equals r sine of theta. And so based on what we're given, r is going to be 4 and theta is going to be pi over 2. So we are just going to do some substitutions here. So x equals 4 cosine of pi over 2. And if you don't remember what cosine of pi over 2 is, you need to look at your unit circle. And hopefully you'll see that this entire value, cosine of pi over 2, is 0. So 4 times 0 is 0. And then for our y coordinate, we have 4 sine of pi over 2. And again, looking at your unit circle, if you don't remember, that's going to be 4 times 1, which is going to give you 4. So our new coordinates, or from our polar coordinates to our rectangular coordinates, it's going to be the ordered pair 0, 4. And we're going to do the same process and use the same formula for number 2. And so looking back over here again, we're just using those same formulas. So x is going to be equal to 5 cosine of 5 pi over 6. And again, if you don't remember, you might need to use your unit circle. And that's going to be 5 times cosine of 5 pi over 6 is going to be negative because you're the second quadrant. And cosine of 5 pi over 6 is the square root of 3 over 2. And so when you multiply that out, you're going to have negative 5 square root of 3 all over 2. And then to do your y value, y equals r sine of 5 pi over 6. And so let's see, that's going to give us 5 times sine is positive in the second quadrant, and sine of 5 pi over 6 should be 1/2, and so that's going to give me 5 over 2. So my new coordinates, if we're going to rectangular, it's going to be my x value, which was negative, let's see, what was it? Negative 5 root 3 over 2, 5 root 3 over 2, and 5/2. And we're going to use the same process for number 3. So x equals r, and then cosine of 4 pi over 3. And I believe 4 pi over 3 is the third quadrant. And let's see, so that's going to be x equals 4 times, well, cosine of 4 pi over 3, I think that's negative 1/2. And so x is going to be negative 2. And then y equals, and again, 4 sine of 4 pi over 3. And so again, since we're in the third quadrant, sine is going to be negative here, and that's going to be root 3 over 2. Now keep in mind when you multiply these, that 2 will cancel into 4, leaving 2. And so we have negative 2 root 3. So our new ordered pair here from polar, again we were given polar, to rectangular will be negative 2, comma, negative 2 root 3. Now for these problems, we're going to be going in the other direction. We are given an x and a y, and we need to find r and theta. So again, keep in mind this is your x comma y. Your answer is going to be your radius r and your angle theta. Now radius r, you already know how to do this. That's your Pythagorean theorem. Let's go through and apply it, and don't worry too much about not knowing where negative 2 root 3 is. As long as you kind of get it in the right area, that would be good. And so notice if I plot this point, I have to go left negative, or left 2 root 3 and down 2. So really I'm going to end up somewhere down here, and I'm just going to go ahead and draw the triangle. And I'm going to label my side lengths. Again, this was 2 root 3, and this side was 2. And again, I did not attach the signs to it because at this point, as long as we've got it in the third quadrant, we're okay to ignore those signs. Now, to find r is your radius here. So we know from the Pythagorean theorem, we know r squared equals 2 squared plus 2 root 3 squared. And again, don't worry about the signs because if we square it, the negative is going to go away anyway. So I get 4 plus, now don't forget to square both 2 and the root 3, and you would multiply those. So that's going to give you 4 times 3, which is going to give us 12. So we have r squared is going to give us 16, so r is 4. So we know this part of our answer is going to be 4. Now we have our radius length. Now we need to know the angle. Now keep in mind the angle that we're looking for, and I'm going to change colors to help us see. The angle in question, our final answer will be this big angle out here. Do keep in mind that big portion there, that's theta. But we only have enough information to find a little angle inside here. So we have to be careful. Now if I wanted to know that angle length measure based on what we're given, we're going to have to use tangent. And we would say tangent of some angle, which is that little angle inside, it's going to be opposite over adjacent. So notice we're looking for a tangent of what angle is going to give me, and I would go ahead and reduce that and say 1 over root 3. And we have to say, well, what angle is that going to be? And let's see, if we got 1 over root 3, then that should be pi over 6 is going to be the angle. But we do have to be careful. Again, pi over 6 is the small angle on the inside. We need this larger angle out here. Now, the way we define theta is going to be the shortest distance or the smallest distance around. So if I go this direction, that's 180 plus pi over 6, and that's not going to be our shortest distance. Actually, our shortest distance, and this is going to seem strange, is going to be from here to here. That's going to be our shortest distance, is from here to here. So we always have to look for that because by definition, theta is the shortest distance. So in order to find this little portion here, well, I knew the inside is pi over 6. So in order to find this portion out here, well, let's take pi, which is the entire amount around from this part all the way out to here. So I'm going to have pi, and then I'm going to subtract from it pi over 6. Now, before we freak out about looking at the pi's, remember that's the same thing as saying 1 minus 1/6, and you just smack a pi on it. So 1 minus 1 over 6 is really 5 over 6. So this up here is going to be 5 pi over 6. So that's going to be my angle measure is 5 pi over 6. Okay, following the same process, let's try number 2. And again, I would suggest that you make a rough sketch. And let's see, what quadrant would this one be? Positive 3 and then negative 3. So that's going to be somewhere down here. And notice I would go ahead, put my 2 side lengths. And remember, your hypotenuse is your r. So r squared equals 3 squared plus 3 squared. And so you're going to get r to be the square root of 18, which is 3 square root of 2. Now, if you remembered your special right triangles, then you wouldn't have to go through all of that. If you happen to remember if this is 3 3, then you know this side is 3 root 2. That's perfectly okay. Nothing wrong with that. But a lot of people won't remember that. That's fine also. There's the process you would go through. So you know your radius length is 3 root 2. Now define theta. And again, keep in mind what your theta is. The theta that we write as our final answer is going to have to be this big angle here. But based on the information we're given, we can only find this angle inside here. And so we've got to find that smallest distance. What's going to make that happen to be this angle here, to make that angle. So let's think about this. We know, again, and it always starts with tangent of some angle equals, and let's see, it's going to be 3 over 3. So tangent of what angle is 1, and we see that that angle is 45 degrees or pi over 4. But again, we want the shortest distance. Now we're tempted to say, well, pi over 4, but remember pi over 4 is positive, it's up here. So really, if we need to move in this direction, our actual final angle should be negative pi over 4. And so here we would say negative pi over 4, and that's going to get us to that angle. Now, an angle that's coterminal with that, well, negative pi over 4, that's really the same thing as 7 pi over 4 if you'd rather do that. Either one's going to give you the same answer. Okay, moving on to the last problem, and this one's a little bit different. And again, we are still trying to convert this x comma y into an r comma theta. We're still looking for some angle here. So again, if we plot this, let's see what we run into with this. Well, 0, 1, that's up here. So, well, what would be our radius length? Well, it looks like our radius length is going to be a 1, isn't it? Because here, again, there's no way to really do our x and y value so much if we're looking at that plotted point. But I mean, if we do, remember r squared equals x squared plus y squared. And notice you do get r squared to be 1. So again, by what we're looking at here, yeah, you get r to be 1. Well, what about an angle here? Well, let's see, what angle would I be at if I went from here to here? And hopefully we see that it is 90 degrees or pi over 2. Okay, with these problems, we will continue the idea of doing some conversions. However, we're going to have to remember a few things with this. Now, we are changing from rectangular to polar, which means we're going to have everything, if we're in polar form, that means everything's in terms of r and theta. That's what that means. So let's think about some things that we know. How are x and y related to r and theta? And we go right back to, well, we know that x is r cosine of theta, and I know y is r sine of theta. And so I know I can make some substitutions there. So let's see, for this first one, y, but in place of y, I'm going to put r sine of theta equals 3 times x, but x is r cosine theta, and then minus 2. So let's see what we have here. I would go ahead and try to get this over here. We really would like this to say r equals if we can. Sometimes it happens, sometimes it doesn't. We have r sine of theta minus, that's really 3r cosine of theta, and that equals -2. And then if we notice there's an r in each term, we have an r here and an r here. So let's factor out that GCF, and we would have sine theta minus 3 cosine theta, and that's equal to -2. And now I think we're just about finished. We are going to have to divide both sides by all of this inside the parentheses. So it looks like we're going to get r to be equal to, and we have -2 over, and it's going to be sine theta minus 3 cosine theta. Okay, and we know we're finished because we have just r and theta, and we have it as r equals. So we know that we have all of this set up correctly. Okay, same idea for the next problem. So let's go ahead, and we do know this relationship, and we're going to use that relationship down here. So in place of y, I'm going to say r sine theta equals -2 times x, and x is r cosine theta. Now with this, the way it's set up, what we need to do is get everything together on one side. It's certainly different than the previous problem as far as adding and subtracting stuff. Here, I'm going to go ahead and divide both sides by r sine theta. And when I do that, this side over here ends up being 1 equals, and notice what cancels out here. And we have sine over cosine. Well, sine over cosine is cotangent of theta. And I'm going to divide both sides by -2. So I have -1/2 equals cotangent of theta. And let's see, we can also write that as -2 equals tangent of theta. Either one of those would be the same. And notice this time we did have our radius value to cancel out, and that will be okay with these problems. All right, now looking at number 3. Number 3, we have x squared plus y squared equals, and we have a 1 here, but we also know that x squared plus y squared is also equal to r squared, isn't it? And so really all of this information we have here, the x squared plus y squared, well, we know it's equal to r squared, so we can make that substitution and say, well, that's really r squared equals 1, or r equals 1. So this would be my final answer. Just like this up here was the final answer. In number 2, we did not have an r value, so to speak. So in number 3, we don't have a theta value, so to speak. It's just going to be a circle with a radius of 1. All right, now we're going to go from a polar equation into a rectangular equation. So we're going to go from theta and radius to x's and y's. We're looking for that. So the first thing we might need to do is rewrite secant. We know secant is the same thing as 1 over cosine. So really we have r equals, and it's going to be 5 over cosine of theta. And now let's multiply both sides by cosine of theta and move that up here. So I'm going to have cosine of theta times r is equal to 5. And we know cosine of theta is going to be x over r. We know that from our right triangles. And then that's also times r, which equals 5. And notice these r's will cancel each other out. So I have x is going to be equal to 5. And so that would be my final answer. Very similar, we would do the same thing with number 2. Again, I would rewrite cosecant. That's the same thing as 1 over sine of theta. And so we really have r equals, and let's see, we're going to have 3 over sine theta. And again, just like before, we're going to multiply both sides by sine theta. So I have sine theta times r equals 3. And we know sine theta is y over r times r. And that's going to give me 3. And so here the r's will cancel each other out again. So I have y equals 3. And that would be my final answer. And so now let's look at number 3. Number 3, we have r squared equals tangent theta. We know that r squared, that's the same thing as x squared plus y squared. We've seen that a few times here. Equals, well, what do we know tangent is? Well, tangent's really y over x. And before we get into way too much algebra with this, we're going to leave this problem just like it is. And this will be okay.